Hey guys, you know what? I thought maybe what I'd do today is kind of give you a little update on what I'm doing with the kitchen and kind of show you some of the work I have to do. Now, I've shown you all this before. We are starting to rip out drywall and so forth because we want to basically have a nice clean slate to work with. This stuff that we've had here is really nasty, textured. It's no good, so we want to clean all that up. Um, but here's a big thing that we want to do that I got to kind of figure out. So what we've had here traditionally, right there, is a an electric cooktop. We want to go to gas. We're going to convert to gas. So we have on order a gas cooktop, but that means I need to run gas up to this place. Now, and we even, this is stuff I would never, ever, ever, ever consider doing myself, except I might do it myself. I don't know. We contacted a plumber and said, hey, can you give us a quote? And the plumber came by, quoted, and it basically came to like, 1,500 bucks. 1,500? Let me show you how simple this is. So right below me, I am going to take you to right below me down into the basement. So I come on over here, come down into the basement. We're going to have some puppies follow. Puppy's like, where are you going? Where are you going? All right, so I come on over here. We come into our storage. Well, now, this is our gas furnace right here, okay? Gas furnace. It does the heating thing. This right here is the gas pipe that feeds the furnace, right? Well, now, right up here is an elbow because the gas comes in from over here, comes over here, goes down to the furnace here, okay? Well, elbow right here, why not just put a T-joint there, bring it on over here, and shoot it up through the floor up to the kitchen? I mean, it's really, really simple. Of course, it's gas, which scares the bejesus out of me, right? How do I turn off the gas? How do I make sure that I'm doing this all right? I know how you test for leaks and so forth with some soapy water and so on. I get that. But I don't know how to turn off the gas. I don't know how to, make sure that it's all legal and so forth. So that's why I think, well, gee, I'm going to hire a professional, hire a plumber to do this. But $1,500? Are you kidding me? All you're doing is adding a pipe and shoving it up through the ceiling there, right? Up through the, I don't know where those puppies are. We'll find them. So my father is coming to visit next week, and he does this sort of stuff all the time. So I'm going to ask him if this is something that we can just do. And I found the puppies. They're over here, and they're playing with a, oh gosh, what is that? A fabric softener. They found a fabric softener. Okay. So that's kind of my big thing right now. Over the next couple of days, I'm going to rip out all this drywall and replace it. But what I really want to figure out is that gas line. So, hey, if any of you know how to put in a gas line or know somebody who doesn't cost $1,500, let me know, because I've got a job for them. All right? So, let's go ahead and get started. Okay. Yeah, it's it's one of those things, and I've experienced this many, many times in my life, and I talk about it a lot, which is to the lay person who doesn't know anything, everything looks easy, right? I mean, how hard can it be to just run gas and so forth? Well, there are people who've gone to school for 2 years and have degrees and certifications and so on and so forth who have learned how to do that and do it properly. But gosh, do I need that? So we'll have to see. Great to have you along. Looks like we've got Scott, Adrian, Laura, Jack. We're getting folks coming in. That is fantastic. Okay. Well, with that, let's go ahead and get started in what we're talking about today. And what we're talking about is, of course, this is the third reading in this particular module, this lecture series on scientific principles of scientific management. Remember when we spoke in our last lecture, we said, listen, we got to have better managers than just the white male relatives of the boss, of the owner, right? We need real, honest, competent managers. And in our last lecture, we talked about Henri Fayol and Douglas McGregor. And these folks really kind of brought the human aspect to organizational management and leadership to bear. We're talking about how to bring individuals to be a cohesive whole such that the whole is greater than the sum of its parts. And that was sorely needed, sorely needed. Well, good old Frederick Taylor here, his world is sorely needed as well. However, with Frederick Taylor, we are not talking about the human aspect. We're talking about the actual, mechanical work, as we're going to see. So we'll go ahead and take a look at that. So let's play with this for a bit. Let's talk about who Frederick Taylor was. Now, by the way, just as in when we talked about Henri Fayol and Douglas McGregor, you were probably looking at that stuff going, well, heck, that's the way people manage today. What's the big whoop-de-doo? Well, at the time, that stuff was revolutionary. And remember, this class is all about going back to the past to see what were the conditions under which we started to implement new practices, and are those conditions still the case today? Well, similarly, Frederick Taylor, you would be surprised and astonished at how much his science affects how we work today. All right. So let's talk a little bit about this dude. Mechanical engineer by trade. Now, remember, Henri Fayol was an engineer as well, but to Frederick Taylor, all problems are a mechanical engineering problem. You know the saying that to a hammer, everything looks like a nail? Well, to Taylor, everything looked like mechanical engineering. He didn't see people as people. He saw them as components, as cogs in a machine. Saw no standardization. Workers content to do what just seemed best for them. How do you do it? I just do it the way I've always done it. Why do you do it that way? It seems to work. Well, why does this person do it differently? Oh, they do it differently. Who cares, right? He didn't see any standardization across the board when he kind of looked at efficiencies. He founded the idea of scientific management, applying the scientific methods to managements, okay? Management. The idea is, all right, scientific management studies and identifies the variables and figures out the best variables and the best components, puts them together, tests, observes, tweaks, all that sort of stuff. So as a result, what Frederick Taylor did was he took the idea of division of labor to the umpteenth degree, okay? looking for the very best way to execute every step within, again, another typo. What was I high when I made this? What the heck? With the fewest number of steps through his time and motion studies. Okay, Frederick Taylor was all about time and motion studies. Now, the idea of time and motion studies is he would take any job and break it down to its constituent parts. I mean, we're talking every action, every motion. And he would measure how long does it take somebody to move their arm, how far to pick up a part to then place it in the assembly line, right? His time and motion studies were revolutionary and are still kind of a North Star for a lot of efficiency improvement today. We're going to talk about that. Okay, so, no, wrong one. So let's come on back over here. So here's a quote by Frederick Taylor to show you what a gem of a guy he was. Hardly any competent workman can be found who does not devote considerable amount of time to studying just how slowly he can work and still convince his employer he's going at a good pace. Frederick Taylor did not have a lot of love for employees. He did not have a lot of love and respect for employees. Whereas he is using the scientific method and his time and motion studies to figure out how to make an employee as efficient as possible, he figured, and we've talked about this in the past, that employees are sitting around and trying to figure out how to get away with doing as little work as possible and yet still convince the boss that they're moving at a decent pace. And so he kind of saw it as this arms race. Now, mind you, he actually does advocate, and we'll talk about this, paying the very best employees very well. He doesn't advocate paying them well because, he's a great humanitarian or believes in a livable wage or anything like that. He just figures, hey, once you find an employee who will put up with the crap that I'm about to set up for them, you want to keep them around because they are highly efficient, highly productive. Now, again, I need to be careful. I don't speak highly of this guy and put up with the crap that he sets up. But he's a genius, and we use his methods today. We'll talk about that. All right? Okay, let's keep going. So, shoveling. Oh my gosh, I didn't bring up my shovels. Wait right here. Oh, goodness. So, you're like, where'd he go? Here's the thing. I had a couple of snow shovels out that I was going to use as an example, and I set them out by the stairs so I could bring them up. Well, my wife must have looked at them yesterday and said, what the heck are these things doing here? And so she put them away, and I have no idea where she put them away. So, you're just going to have to bear with me without my, I ran up the stairs, without my actual shovels. Okay, so we have a house. It snows here in Utah. And so I needed a snow shovel. So I went to the store and I bought this really cool looking space age awesome metal shovel. It just looks like something out of a Buck Rogers old cereal show. And so I said, okay, I'm going to use this one. Well, my wife started using it and she hated it. She really hated it. And so she went to Walmart and bought a piece of crap shovel that probably meant for kids or something, right? Just a really, really cheap plastic shovel. Well, here's the thing. The cheap plastic shovel is infinitely more effective and efficient than the great big shovel. The great big shovel picks up way too much snow. And so when you shovel with it, it picks up so much snow that you can hardly lift it. And so you're kind of struggling with it. Furthermore, because it's big and it's metal and it's bulky, it has a lot of weight in and of itself. So even if you pick up, say, half a load of snow, you're still picking up a lot of weight just because of the shovel. Whereas this cheap Walmart shovel, it's really, really light. It picks up the perfect amount of snow, and you can go to town on a driveway with this cheap Walmart shovel and be done in no time flat. Whereas the great big shovel, you might look cool with it, but it's pretty useless. Well, this is kind of what Taylor figures out in terms of how to design equipment and how to design work processes and how to train employees to use the equipment in these work processes. Now, one of the stories that the reading talks about is Galbraith and bricklaying. Okay, now for those of you who have looked at the reading or you're going to look at the reading, let me kind of set the stage for you a little bit. In the reading, Taylor tells the story of how Gilbreth used his methodology to improve bricklaying efficiency. So in a way, Frederick Taylor is kind of using Gilbreth, I don't know how to pronounce that name, as a testimonial, if you will, a case study testimonial. Okay, so let's take a look at this to really see how Frederick Taylor's time and motion studies worked. So for hundreds of years, there has been little or no improvement made to the implements and materials used in this trade, bricklaying, nor in fact in the method of laying bricks. In spite of millions of men who have practiced this trade, no great improvement has ever been evolved for many generations. All right, fair point. Millions and millions of people have laid bricks over centuries, and there's no standard method. There's no great improvement. They just do it the way they do it because that's the way they do it. For Frank B. Gilbreth, a member of our society, you see, kind of case study testimonial, who had himself studied bricklaying in his youth, became interested in the principles of scientific management and decided to apply them to the art of bricklaying. Okay, the stage is now set. We're going to take this antiquated practice of bricklaying and we're going to apply the scientific method and time and motion studies to this practice to see if we can get some efficiency. Okay. He made an intensely interesting analysis and study of each movement of a bricklayer. And I mean each movement. A time and motion study will measure how long and how far did it take you to reach. How long did it take you to reach how far? How many bricks did you pick up? How did you place them? How far and how often did you have to bend down to pick something up? I mean, we're talking every single movement. And one after another eliminated all unnecessary movements and substituted fast for slow motions. This this is the core of the scientific method and time and motion studies. Let's look at all the motions, let's look at all the time, and let's remove every motion that does not add value to the whole process and replace them with something that does. He experimented with every minute element in which in any way affects the speed and tiring of the bricklayer. Okay? All right. So, he developed the exact position to which each of the feet of the bricklayer should occupy with relation to the wall, the mortar box, and the pile of bricks, and so made it unnecessary for him to take a step or two toward the pile of bricks and back again to each time he laid a brick on the wall, right? So, in other words, he figured out exactly where the worker should stand, exactly how far away from the wall, exactly where the bricks should be, where the mortar should be, so that there would be as little movement as possible in the process of laying bricks. He studied the best height for the mortar box and the brick pile, and designed a scaffold with a table on it upon which all of the materials are placed, and so keep the bricks, the mortar, and the man and the wall in their proper relative positions. So now he has this whole apparatus around him, the scaffold, that he can just bring along the wall, and everything is in its place. Okay? Through all this minute study of motions to be made by the bricklayer in laying bricks under standard conditions, Mr. Galbraith has reduced his movements from 18 motions per brick to 5, and even in one case as low as 2 motions per brick. But let's just go with 18 to 5, okay? Just imagine how much motion and time and cost savings there is if we have a process that in the past took 18 motions and now it's just down to 5 motions. All right. So now let me ask you this, and this is where we'll start stacking things up here, right? And Laura, I saw your comment on the repairs and so forth. Yeah, I will not be efficient in those repairs. Let me tell you that. So let me ask you this. All this that we've seen, trust me, you have experienced this in your own life, either by your own design or by your employer's design or who knows what. Trust me, you've experienced this. In what way have you experienced the outcome of a time and motion study wherein the process that you followed reduced the time and number of motions and number of this, that, and the other, number of steps to get something done? So let's play with that. Okay, fantastic. We're going to play with these, but in the meantime, we've got this going on up to 8. And we've got this going on up to 7, or to, yeah, I'll just say 7. Why not? Okay, fantastic. Let's play with some of these, all right? So, let's see. Adrian says Amazon does a great job of this because of their conveyor belt. They have a person in each position and so forth. Yeah. So when I worked at FedEx, I worked in the hub. And so conveyor belts at 3 a.m., that sort of stuff. And that's classic sort of time and motion study, right? By the way, all of you have experienced it with Amazon, because how many clicks away is what you're looking for on a website? So for example, when you're signing up for a class at Salt Lake Community College, there's a lot of extraneous clicks. I mean, I don't need, I already told you it was this semester, and then you're asking for another semester, and then it asks you for this and this and this and this. And so it's like 6 or 7 clicks to sign up for a class. When I could easily make it 4, right? Same thing with Amazon. If you're all set at Amazon, you can say buy with 1 click. Buy with 1 click. Talk about removing friction, right? So, and then Mauricio says sighting and a rifle scope. I have no doubt that when it comes to military training and so forth, they will train you to do, they'll tell you how to do, what to do. They'll tell you exactly what order, what process, how long it should take, and they will test you over and over to make sure you're doing the right thing in the right order in the right period of time. Yeah. Scott, when I was in high school folding newspapers, I had a paper route as well when I was a kid. And yeah, they would teach you exactly how to fold, how to put in the inserts, how to put on the rubber band and everything so that you can get it done as quickly as possible. Adrian, the kitchen. Yes. Okay. Making a sandwich and so forth. So Adrian, you're absolutely right. In the kitchen, if you're like a big time chef or whatever, it's called mise en place. Mise en place means everything in its place. It's French for everything in its place. And when you have mise en place going on, you can prepare a meal very, very quickly and very efficiently and with high quality with very little effort, right? Adam Savage in his workshop calls it first law of retrievability, or order of retrievability, first order of retrievability. In other words, put the things that you use most closest, put the things that you use least up above or down low. Laura, at work, adding second monitor to work to reduce the time. Yes, that's why a lot of folks use second monitors, so you don't have to, fold down screens, reduce, bring them up, reduce, bring them up. Yeah. At home with furniture painting. Very nice, Laura. We're going to put some real world examples in here. In door-to-door sales, I figured out that if I didn't spend time going around their yard and went straight to the door, I could save time. Adrian, yes, exactly. Okay, exactly. Tremendous. So I'm just going to go ahead and take this on up to 8. We're going to, or 7. We'll give our awesome comments up there. And there we go. Our timestamp for today is 10:24. So after the lecture, email me 10:24, and that is the timestamp we'll do. All right. Fantastic. Very good. And of course, it's just going to keep going up. You know how this works. Okay. Very good. So the point is, and you guys see it really, really well, this is everywhere. This is everywhere. Okay. So with that in mind, let's talk a little bit about why he has set this up. This is one of the cases of where we see that he does not have a lot of faith in workers. He believes this should be a very much tops-down process. It is highly unlikely that many times during all of these years, individual bricklayers it is highly likely that they have recognized the possibility of eliminating each of these unnecessary motions. But even if in the past he did invent each one of Gilbraith's improvements, no bricklayer could alone increase his speed through their adoption, because it will be remembered and that in all cases several bricklayers work together in a row, and that the walls are all along a building must grow at the same rate of speed. No one bricklayer then can work much faster than the one next to him, nor has any one workman the authority to make the other workmen cooperate with him and do faster work. Okay, so what's he saying? Because I don't read aloud very well. He's saying, listen, let's say that there's one bricklayer who can figure out the Gilbreth method perfectly. He still can't really implement it because, first of all, he's the only one doing it. He does not have the authority to tell other bricklayers to follow this method. And since all the bricklayers are working together going down the wall, they're basically going to go at the speed of the slowest person, all right? The weakest link, if you will. So they're all going to move down the line at the speed of the slowest person, and that's as good as it's going to get. Whereas if you have top down, the bosses directing and training and measuring and rewarding and punishing people who slow things up, then you can get everybody to work faster, right? So interesting idea. It is only through enforced standardization of methods, enforced adoption of the best implements and working conditions, and enforced cooperation that this faster work can be assured. And the duty of enforcing the adoption standards and of enforcing this cooperation rests with management alone. Notice his emphatic restatement of enforce, enforce, enforce. Managers think, employees do, okay? The employee is there only because we have not found a machine that will do it faster. And by the way, Adrian, it was just announced that Amazon is testing out Stretch, right? Have you heard about Stretch? Stretch is a new robot developed by Boston Dynamics that loads boxes onto the belts and so forth. And they're testing out to see if Stretch will work, all right? Frederick Taylor, you and I employees, we are just cogs in the machine. And as soon as we can replace the cog with a more reliable cog and faster and efficient cog, such as a robot or a machine or a computer, he will. Okay? All right. Now, here's the thing. I'm speaking about this as though I'm dissing it. But I'm a fan. Okay, Adrian says, in warehouse I used to work, it's going to be implementing and most people will be fired. Yeah, that robot's going to replace you. Which, Adrian, is why you're in college. Stay in school. Because that robot cannot go to school and learn more stuff like you can. So you still have the edge. All right. I'm a fan of efficiency. I am really a fan. And let's see. The name, Scott, if you Google Boston Dynamics and stretch, you'll find it. I'm a big fan of efficiency. I am a big fan of efficiency. I have checklists. I have processes. I use them when I'm doing my live streams and so forth. So while Frederick Taylor took it to kind of a inhuman degree, he's right. Now, by the way, this picture here, so this is what you're talking about. Wrong one. This is what you call a Rube Goldberg machine, okay? Rube Goldberg it was a cartoonist who would create, as Scott says, overly complicated machines to do very simple tasks, okay? Over-engineering to the umpteenth degree, all right? Now, you're going to think this is ridiculous. You're going to think this is ridiculous, but it's not. Please open your mind to the idea that I am going to ask a serious question. I'm going to first show you how this machine works, and then I'm going to ask you to identify areas of waste. All right? So, here's the deal. This is an automatic napkin dispenser, okay? Automatic napkin applicator, I should say. So, here's the idea. This dude here, step A, he raises the spoon. This pulls this string, which actuates this spoon. That flips this cracker up, okay? And Polly here, the parrot, starts to eat the cracker. As he eats the cracker, he dispenses the crumbs in his cracker dish. These crumbs fill up this bucket, which pulls open a lighter, okay? This lighter lights the rocket, and the rocket shoots up, which pulls this sickle. And the sickle cuts the string right here. And as it cuts the string, it lets loose the pendulum, and the pendulum on the clock starts to move back and forth. And that sends this napkin back and forth over the man's mouth. Simple. So, the question I have for you is, in what way is this wasteful? Call out the specific things, steps, processes, ingredients that are wasteful, and let's see what we come up with. Trust me, there's a lot to be figured out here. Okay, let's come back. And by the way, I saw, Scott, it's like Pee Wee Herman built the machine. Yeah, absolutely. All right, let's go ahead and take a look at these. You've got some good points. So, you know, one of the things that Adrian said is you could just, you know, have a lever connected to the spoon. So when you lower the spoon, the napkin goes over your mouth and so forth. Yes, there are many, many, many non-value add steps. Okay. Non-value add steps. Non-value add steps. What do I mean by non-value add? Now, value add is a term that is often used, well, too much, all right? And yet we don't really know what it means. Value add means, does that step add value to the product or service that you are creating, right? Like Alma says, not needed. So, for instance, right, now I bought this cable, and this cable has each one of the ends already attached. Now, I could buy just the cable and just the ends, and that way I can make my own cable at the length I want, with the ends I want, the inputs and outputs, and so on and so forth. But this one comes pre-assembled, and therefore the steps of adding this are value add. Ultimately, what we want is a napkin dispensing device. And the vast majority of the steps here do not make that napkin any better than just picking it up yourself, right? Let's keep going. So, no need for the bird, right? Jack says, okay, so, ingredients, right? Or the supplies or resources. Resources used. There's a lot of wasted use of resources. We don't need a cracker. We don't need a lighter. We don't need a rocket. We don't need a bird. Another thing about this bird is that bird occupies a separate subsystem, and you cannot control that subsystem. So, for example, the clock is a separate subsystem because it has a mechanism that makes the pendulum go back and forth. But for the most part, you can control that, right? You can wind it, you can make sure it's well maintained, so on and so forth. You know what a pendulum is going to do. It is a separate subsystem, but it's controllable. That bird is not controllable. So when he wants to do his own damn thing, he's going to do his own damn thing, okay? The whole thing is based on one part. The lever swings, yeah. You know, it can all fall apart there. You're right. Take forever to get the bucket filled. Okay. This is not a timely delivery of the service. All right. So he needs that napkin soon after taking a sip of soup. However, if we calculate for all the time that it takes to get that napkin going across, first of all, it could take forever. Second of all, it's not really it's not something we can calculate for because we don't know about the bird and all that sort of stuff. Okay? Very good. But there's more. There's more. Let me show you some other things that we're going to play with. I want to talk to you about lean. Many of you have probably heard of Six Sigma. Six Sigma and lean. Six Sigma is a process you go through to make a process more efficient. And lean is kind of a subset of Six Sigma. Lean is all about eliminating waste. Six Sigma and lean are direct descendants from Frederick Taylor. We have Frederick Taylor to thank for Six Sigma and Lean, and frankly, they're pretty darn awesome. All right. But let me just talk to you about Lean. Lean looks for the elimination of waste, and it is so hyper vigilant to the elimination of waste that it goes into depth to define waste. Now, our Rube Goldberg machine that we saw there before, totally wasteful. Let's look at how it's wasteful. One thing that is wasteful is overproduction. Now, we didn't call it out there before, but that system that he had overproduced the service that he needed. Once that pendulum started going back and forth with the napkin, it was just going to go back and forth until he stopped it. He only needs 1 or 2 swipes of the napkin, but he has a perpetual supply of that service, and he does not need a perpetual supply. And overproduction can be very expensive and get in the way, and so on and so forth. Okay? Also, waiting. You guys did point this one out. You'd have to wait forever for that whole system to work. And any time that you're waiting, you're wasting some sort of resource. Now, obviously, if an employee is sitting on their hand, it's pretty obvious how that's wasteful. You're paying that employee. But even if equipment is not being used, it's wasteful. So, for example, I paid, I don't know, some $800 for this microphone. If I only use it once, that was an $800 use. However, if I use this microphone 800 times, it's a $1 per use. Well, that's far more efficient in terms of my financial resources, the expenditure of capital. And so the more you use something, the more efficient its use is to your bottom line. Okay? Transportation, movement of materials and so forth. Moving things all about and so forth. Adrian, you know all about this at Amazon. They want to make sure that anytime you move material, it is to put it in a better situation for accessibility or delivery. You don't just move it at random. Extra processing, right? Or reworking something if it's not right. Defects, right? Which we'll talk about in a moment. But extra processing. For example, I'm doing a new lecture series that is not live. However, I'm using the same setup to publish this lecture series very, very quickly. I don't want to have to take the lecture series through post-processing because post-processing takes more time. And for this particular series, I'm willing to let go of that for efficiency and time's sake. Inventory. We hate inventory because inventory takes up space. It loses value over time. And it's a great example of sunk cost. You've put your money into this product, but you can't get your money out of that product until you sell it. And if your inventory is just building up, that means you've created a whole bunch of stuff that you didn't need and it's taking up space, which you need to pay for, and you spent money on it and you're not getting the money out of it. Inventory, very wasteful. Motion, unnecessary motion, inefficient motion, and then of course defects. The whole point of this is the sort of stuff that the time and motion studies and now Six Sigma and so forth look at to figure out, how can we be most efficient? So, in closing, here's a quote from Frederick Taylor. In the past, the man has been the first. In the future, the system must be the first. Oh, I can't tell you how much I hate that idea, right? But to put it in a way that I actually really agree with is If you set up really good, strong, robust, efficient, and effective processes in your life is so much easier. So much easier. Okay? So I strongly encourage you to do that in your life. Make efficiency a habit and set up systems and habits that work to your advantage versus systems and habits that work to your disadvantage. Okay? And lo and behold, there you go. That is Frederick Taylor and his time and motion studies. You should be totally set now for the week. And then when we come back, oh yeah, we're starting to get into some really good stuff. It's all good stuff, right? But we're going to get into some really fun stuff about consumerism next week. And I'm really looking forward to that. So as always, I'll stick around in the comments if you have any questions in the chat. And in the meantime, you guys have a great rest of the week, and we'll connect again on Monday. Have a good one.